Starting the video now. All right, thanks so much for joining us today, everyone. I'm Chloe. I'm with Tri-County Regional Energy Network, and we have Tatiana and Jennifer from Imbalance joining us today for this training. Thanks so much for joining us. This is the last part in our all-electric design and construction series. So for anyone who's joining us for the first time today, you got here just in time. And for everyone else, we're so happy to have had you for the past 4 trainings. I have a few announcements before I go ahead and hand this over to Tatiana and Jennifer. And the first one is super important. So if you weren't paying attention before, please pay attention now for a couple of minutes. We are going to be sending you all a survey after today's training. You're probably going to get it on Monday, maybe on Tuesday. The email is going to say, thanks for attending part 5 of the All Electric Design and Construction series. It's going to have the slides from today, a recording, and also a link to take a survey. The survey is super quick. It will only take you a couple of minutes of your time. It's about 4 questions, and most of them are multiple choice, so it's really easy to fill out. I'm really going to encourage everyone to take a look at the survey if you have enjoyed the trainings for the past 5 in this series. We use feedback from these surveys to give us an idea of what sort of training we can provide in the future. So if you guys liked this and you want to see more trainings like this from the 3C Ren team, definitely let us know. The more people who say, I would like to see this training again, the better chance we have of being able to offer it again soon into the future. And additionally, if you have any ideas for other sorts of trainings you'd like to see from us, you can let us know. We are always designing new trainings and thinking about new things we can offer to you all. So if you give us that feedback, we will definitely take it into account. I personally will read every single response we get to this survey, so your feedback is definitely going to be considered. And then a few quick reminders before we get started with the training for today. The first is just to make sure that you are staying on mute for the duration of the training, just so we can hear our speakers. If you have any questions, you can either add them to the chat or you're welcome to raise your hand and we can unmute you when there's an opportunity for contribution that way. The session is being recorded, so if you prefer not to be recorded, make sure you stay off camera. And then most importantly for today, we are going to be using Zoom attendance to distribute the ZNCD and AIA learning units. So that means that if you would like to receive learning units for today's class, make sure that you have registered for this training and are joining using the link we sent you to your email. So if you're joining from someone else's Zoom link, or if you're sharing a screen with a coworker, or if you called in today, I'm not going to have your attendance recorded on Zoom, and you're not going to get credit for attending. So if you think you might be in that situation, please send me an email and I can manually mark you as attended for today. If you're not sure if you fall into that boat, go ahead and email me anyway, and I can make sure that you're definitely going to get credit for coming today. Great. And then quickly, for anyone who is tuning in for the first time today, I'll tell you a little bit about who we are. We're the Tri-County Regional Energy Network, aka 3C Ren. 3C Ren is funded by ratepayer dollars that we all pay into our utility bills through the public goods charge. The benefit of being ratepayer funded is that there is no cost to those that we serve, and as a regional energy network, we're able to return these dollars back to our local economy, which has historically missed out on some of these funds. We can go on to the next slide, thank you. 3C Ren currently offers 6 programs focused around 3 services. These include incentives, training, and technical assistance. The series today has been a part of our Building Performance Training Program, which you can see in orange on the screen here. You can see additional trainings that are being offered through BPT and Energy Code Coach, and learn more about our other services by visiting our website, 3c-ren.org. Since 2019, 3C Ren has had over 4,000 individuals attend training, answered 334 Title 24 and Cal Green questions, and secured $155 million for investment in the Tri-County region. We've also completed over 1,000 energy-saving projects in this area. Everyone on our team is really excited to continue growing in all these areas in 2025. And with that, I will hand it over to Jennifer and Tatiana for today's training.
For my finger jumping around with my mouse on those slides. That was an accident. I think my mouse is sensitive here. Um, Welcome. I'm Jennifer Minnick, licensed architect, certified energy analyst, and I'm here with Tatiana today, who is lead AP, and we are going to talk to you about all electric appliances as part of that all electric package, and kind of follow up on the prior presentations. So this is the fifth one for the Zero Net Carbon Design series, focusing on operational carbon reduction. You will get a copy of the slides. You'll get your AIA unit and your ZNCD unit if you need that for your architecture licensure. Today, we're going to do just a couple slides on kind of California's clean energy goals, and then we're going to jump right into stovetops and ranges as part of the all-electric appliances, electric clothes dryers, electric car charging, and touch on battery energy storage, which relates to solar PV, as a lot of these either appliances or pieces of equipment are now more and more part of our buildings and homes, like the car charging, for example. You used to go to your gas station, but if you've got an electric car now, you're relying probably on the building that you live in or place of work, and in addition to superchargers to charge your car. So they're becoming a part of our building all electric discussion. So California has clean energy goals. We've been working on having clean operational energy and a clean grid in California for the past 50 years. And our buildings are becoming increasingly decarbonized. California is looking at the industrial sector to make sure that that whole part of how we manufacture our goods and products, a lot of which go into our buildings, are being at least created with clean electricity and clean fuels, such as green hydrogens, meaning hydrogen technology, where we're using excess solar to create the hydrogen that's then can be used in our industrial sector and in transportation. And more, we're looking at zero emissions and electric vehicles and electric hybrid vehicles, as well as hydrogen vehicles for cleaning up our transportation sector. Kind of the big picture goals for the 2022 Energy Code, and that includes the 2025 updates, because we're just improving on what we had in the 2022 code a little bit under 2025. So we're going to continue to encourage heat pump technology for space heating and water heating. We're going to continue to establish electric ready requirements for occupancies, especially the single family home occupancy, expand our PV systems and battery storage standards, and continually strengthen our indoor air quality ventilation standards. The appliances that are part of this all electric dwelling or building, could be a commercial building as well. These appliances, stovetop ranges, dryers, car charging, we kind of mentioned, solar battery energy. The main thing here is that our stovetops and ranges and our dryers, for example, in California, could be powered by fossil fuels, by gas, natural gas. So as we move to an all-electric project, now we're looking at what is a better replacement for an electric resistant stove and range. AKA we're going to have induction cooking and convection ovens. And then what's an appropriate replacement for our electric resistant dryers. Electric, it's still electric, but condensing or heat pump dryers are coming on market, which are more energy efficient. Car charging, there's a number of options we're going to go through where you can take care of your car charging both at the building scale, but also at superchargers. And then solar and battery energy storage. We're going to talk a little bit about that and what's available. And to learn more about that, I think in March, we're doing a whole course that's going to dig into the solar, but specifically the battery energy storage. So with that, I'm going to turn it over to Tatiana to go through the stovetops and ranges portion of this.
Thanks, Jennifer. So before we start digging into some of the examples, we first want to take a moment to reflect on where things were before with electrification in stovetop and range appliances. So in the past, gas and electric resistance were the most common types of stovetops. The idea of electric cooking was mostly associated with the old coil electric resistance types of appliances. And clients sometimes would be seeking a specific look for their kitchen range, like in the photo below. And there used to not be a lot of options available to go with induction. So now there's a much wider range of induction options, from high-end appliances with all the bells and whistles to more affordable options. And just a couple of reminders that induction needs stainless steel or cast iron cookware. And induction is also faster than both electric resistance and gas. And on top of that, it's more energy efficient. So there are affordable, portable 1 and 2 burner induction cooking options like the ones shown here. And we found that some libraries have portable induction cooktops that you can actually borrow and try out. We know that the San Luis Obispo, Santa Barbara, and Ventura libraries have them, but you can also check your local library and see if they have them. It's a great way to get a trial run on induction before committing to it in your home or your client's home.
Oh, and Tatiana, sorry to jump in. I just thought that maybe not everyone still quite realizes what induction is. And when you mentioned the cookware, if you can put a magnet to it, then it's going to work with induction, because how induction is heating the pots and pans is it's sending an electric current through there, and it's basically creating a magnet that is vibrating your pan. And so that's one way to test, especially if you're going to check one of these out from the library, if you can use your existing pots and pans. If a magnet works on it, you can use it on induction.
That's a great point. Thank you, Jennifer. So on this slide, we have a list of induction cooktop and range brands available at various Central Coast retailers. The brands with an asterisk next to them are on display in the store, and you can go in person to look at them. And this is not all of the brands available. There are many more, especially at Home Depot and Lowe's. So if you're in the market, take the time to go in person, poke around their websites as well to see just how wide of a variety is available now. And you can kind of get a sense of the variation in pricing, which will depend on the brand, the size, and features available. And so we're gonna walk through a few of those options now. So first we have this 2-burner induction cooktop running at about between $95 and $140. This one's pretty widely available. You can see Home Depot, Lowe's, manufacturer's website, and other online shops. This one's, again, just 2 burners, so it's compact, and it plugs right into a 120-volt outlet, so it does not require professional installation. Next slide.
Sorry. I clicked it. I missed the thing. I was looking at the chat. I saw there was a few things flipping through on the chat about induction and stainless steel cookware and magnets don't work on it. So does an induction work? I have an induction cooktop and my cast iron stuff worked great. Everything that was sort of built as stainless steel cookware worked, but I did have one small pot that didn't work at all. And I did the magnet thing and it didn't work, and it doesn't work on the induction. And it's, yeah, there's a coating. It's like stainless steel coated, but I learned that that piece of cookware doesn't have enough steel in it. And like but like my Le Creuset or like the all clad stuff does work. So that's kind of the test. If the magnet's on it, yeah. And it, right. Someone put in the chat, depends on the core of the stainless steel pad. Yep, that's right. So that's that feedback. So, okay, back to you, Tatiana.
Thanks, Jennifer. So this is an example of a higher end 2-burner induction cooktop. This one's pricier than the last one we looked at, running between $1,300 to $1,600. Jennifer and I saw this one at Ferguson. It's also at Idler's and again online. And this one has a 15-inch surface with 2 burners and illuminated touch controls. And this one is hardwired. So compared to the other model we just looked at, that's just plugged in. So it's a higher end product. It looks really sleek and doesn't have that visible cord that the one on the last slide would have. So for the more standard size induction cooktops, the first one we're looking at here is an affordable example. This is the Frigidaire 5-burner induction cooktop. This one's cost ranges from $900 to $1,100. And although it's more affordable than even the 2-burner Wolf cooktop, this one is Energy Star certified, which the other 2 were not. And this one is pretty widely available as well. And for a higher end induction cooktop example, we have this Thermador model for a little over $6,000. Rather than having a designated number of burners, this option has 36 inches wide of fully usable cooking surface with room for up to 7 pots and pans. It is Wi-Fi enabled, has a full color touchscreen display, and it's shown here in this photo with a 36-inch downdraft ventilation in the back that rises up with the push of a button, which also has lights to illuminate the cooking surface. So this is an example of one of the options that has all the bells and whistles. And there's a lot of room in between those options as well. So onto the ranges. This is an affordable Frigidaire range costing between $680 and $1,000. This is another one that's widely available at Home Depot, Ferguson, Best Buy, as well as online. It has 5 induction burners on top with rear panel control and dial controls for the burners.
And this one, Tatiana, these are priced, right, to kind of compete with gas models.
Yes, yes. This Samsung one is slightly more expensive at $1,300 to $1,600. It's a little bit sleeker than the last option and is Energy Star certified. This is another one that's widely available. It has Wi-Fi connectivity, and you can see the touch controls in the photo below. And on the pricier end, this is the GE Cafe induction range running between $4,000 to $4,500. This one, again, we saw at Ferguson's, also at Home Depot and Lowe's. It has 5 induction burners controlled by the dial controls. This could be one for clients that are going for maybe a specific look in their kitchens. It comes in a bunch of other color options as well. And in the photo on the right, you can see an example of what it looks like with some of the other appliances in the same line.
Thanks, Tatiana.
Yeah.
If there's any quick questions on the induction, feel free to put those in the chat. Yeah, go ahead.
We had a couple of questions about the induction cooktops that maybe you could answer for us, Tatiana. Let me scroll back. Okay. The first question is from Joanna. Does an induction cooktop have to be glass? There are concerns with certain user groups with having a glass top for the range.
It's glass. It is. They're
Okay.
all a glass, but it's incredibly strong. I have one. It's been more durable than some of my other appliances that were more prone to scratching and denting from the paint on the surface where the burners were.
Okay.
Yeah, it's incredibly durable. That was well tested. I haven't heard of any incidents where people have broken them. But I'm sure if you take a sledgehammer to something, anything, any appliance. Someone said they have a chip on their edge with a Le Creuset lid. You chipped it. That's the enamel on my pot chipped and the glass didn't. So, that's my experience. So we'll see. Yeah, I had to replace it. Oh, that's a bummer. I see that in the chat. I guess
and then
it
the
can
other
happen.
question,
Maybe brand specific.
The other question we had was on that
But it's
same
the edge
vein.
they said on theirs. Yeah. Okay, go ahead.
Okay.
And then we'll move on to the next
Okay.
topic.
In that same vein, are there options from Jake? Are there options for range tops that are not terribly expensive to replace? I think you covered a lot of that with the different range models, but Jake, if that didn't totally answer your question, let us know and we can provide a little bit more detail. That is all for me.
Okay, thank you. Okay, we're gonna now, so now we're moving to the laundry room. So, a lot of folks in California might have a lot of electric appliances, but it's really common, especially in our tri-county regional area, to have a clothes dryer in a single family residence that is gas. And so there are options now to have an electric clothes dryer that's more energy efficient than a standard electric resistance heat type dryer. And when it comes to electric dryers, when you're looking for these online and shopping for these, they come basically in 2 models. The way the marketing is set up is they're vented they're vented electric dryers. Also, your gas dryers are vented. So the vented varieties send moisture laden air to the outdoors through the vent. And then with the ventless variety, they're using a condenser. So something that gets very, very cold to condense the moisture in the air onto that cold fan coil, and thereby removing the moisture out of the air and drying the air out. So it's more gentle on your clothes. So, and then these ventless come in 2 varieties, one that's called condensing, and then the other is a heat pump, meaning there's a small amount of refrigerant that's making that condensing coil even colder to condense more water out of the air. And the price range on these is about $800 to $1,600. And you can go to the resource guide.pgne.com and also energystar.gov to find out more about these dryers and to find out what's available in our area. I included this slide for you because Bosch, we're brand agnostic, but Bosch I thought had a great kind of diagram, especially all the architects online to look at, okay, what are they talking about? Where the warm air with moisture from your clothes now is pulled in through a condensing coil. The water condensate drips out, it drains away, and then the air is out. Air from your room is pulled through the whole appliance and sent into the space. The reason it's important to understand that's how the dryer works is that you, as a designer, you need to look for or work with two things typically, is the condensate that comes from the dryer, whether it's a condensing or a heat pump type, they both have condensate. And then also there's some additional maintenance and cleaning with that. And depending on the model, some of these are self-cleaning and self-draining. And you also need a certain amount of net free ventilation area with the dryer, similar to what we were talking about with the heat pump water heaters needing a certain amount of net free ventilation area or volume of space, because this technology does depend on a volume of air to basically utilize for the heat pump or for the condensing technology. And so case in point, this was from my nephew's apartment. He had the Bosch heat pump dryer. Bosch also makes the condensing type. And the apartment building owner didn't quite understand how they work, but knew they were ventless. And it was definitely an upgrade from what everyone had before. But they put solid doors on the closet. And then my nephew learned the hard way that when he inadvertently closed the doors, put the laundry in, closed it up, it looked clean, his clothes weren't drying. He was very upset. A lot of other folks were upset until everyone learned that you have to keep the doors open and open to the rest of the space. This is incorporated into the small bathroom in this apartment, so they really have to keep the bathroom door open, the closet door open. So I'm just giving this as like a heads up. I wouldn't combine these with another room that has a lot of moisture, and you want to use a louver door, and you want to make sure that you get plenty of ventilation in the space. So homes are probably okay. Small apartments, they're super functional, energy efficient, compact, don't require venting, but you need to plan for that. These are available at all the usual places like Home Depot, Lowe's, Ferguson's, Idlers, even Costco has them. And then we put an asterisk by the ones that we know had products on display in those stores so you could see them. And they do, like your typical like gas dryer and electric resistance dryers, they do have sort of the standard and the ultra high-end features like wrinkle guard and pet hair removal, etc. And then there's the new market, the 2-in-1 washer dryer that is also utilizing this kind of heat pump technology. And it's less expensive to buy all in one than it is two separate appliances, but you can, the sale price starts out at like $1,300 and then goes up from there to about $3,000. But some of them have, the higher priced ones have the hair pet removal and de-wrinkling settings, etc. And it's just 120 volt standard outlet on these. And then the no dryer vent, of course, is the main thing. And then with the standard capacity ventless options, really, you're going to just want to look for the heat pumps that have the rebates with them. So there's a lot of times, so when you go online, you can also look up your zip code and find out if your area has a rebate. They do have, when you're also looking for these, whether it's the PG&E.guide or on other online sources, they are marketed as ventless, so just keep that in mind. And the price, varies a little bit, but there are a lot of the standard ones are just trying to price it equal on par with just the vented standard electric dryer, for example. And then there's also large capacity ventless options now. For a while, it was just the small capacity, but now they've got like the 7.8 cubic feet dual inverter heat pump ventless models, for only just over $1,000, and you get those rebates with that. And I looked it up for the San Luis zip code for the fun of it. Highlights those. So the technology's come quite a bit. It's improved a lot. And the only thing I've heard, other than if you didn't have enough airflow, like from my nephew, is that they operate by drying the air out, not by heating and baking your clothes. So when you're trying to have it run on its most efficient mode, it's going to take maybe longer than if you were heating it up. And then some of the dryers will do both. They'll actually have some of the electricity go into heating the air, plus using the condenser to dry it. And you can speed up the cycle that way, or you could do the more ecological, less energy, the eco mode, and it'll just take longer. But other than that, people seem to like them. With car charging, we have basically, let me pause. Any quick questions that came through before I go to the next appliance?
There was one that just came through. For a ventless dryer in an apartment example, would it be beneficial to add a bath fan in the laundry closet?
Probably would. Probably would. I've seen online that what some people did to help improve their situation, and most of these were coming from Europe, because the ventless condensing or heat pump dryers are really common in Europe. And when they talk about doing their home upgrade, they'll get one of those appliances and they will add an exhaust fan into the space, whether it's in a bathroom or a laundry room, but whatever that room is, they'll add the exhaust fan. And when we talked about the indoor air quality session, we talked about inline supply fan. Then some folks just add that. They'll add a new supply and exhaust just to help get the air volume they needed for that dryer. So it really depends on your specific situation. When it comes to charging our cars, if you've got an internal combustion engine or a hybrid, you fill up the gasoline at the gas station. But now with electric cars, more and more, we're asking our community infrastructure and our building infrastructure to be able to accommodate our transportation energy needs by plugging in. And there's the trickle charger type that just plugs into a 120 volt, takes a lot of time to charge up your car. Then there are level 2. You can have the level 2 at your home, which is like a 240 volt charger. And then there's even really kind of a cool invention now called the smart circuit splitter. This is from Neocharger, and it's a little bonus. It's a San Luis Obispo based California based company, but they have a plug-in device that you can use in an existing 240 volt outlet that you might have for that electric dryer. And if that's located in your garage, you can plug that in and then you could plug your car into one end and plug the dryer into the other end. And then you don't have to have the necessarily the cost of the added electrical work to have a charger installed at your house. There are a lot of brands of level 2 chargers, and many of these are specific to the car charging brands. But as Tesla superchargers were installed and their charger type became became more predominant, many car manufacturers are coming out with, they either have their adapter or the cars themselves starting in 2025 are going to be able to accept that car charging type. So then more and more, a lot of these car chargers will be able to be used with different brands of cars with the appropriate adapters. But there's a number to choose from now. And kind of the 3 tiers of this is starting with the least expensive, kind of highlight a couple bullet points there in the middle. Most of them are plug-in 110, 120 volt, and they're only about 15 to 20 amps. There are a couple that are plug-in 240 volt, but most of them are the 110. They cost under $100. You can pick them up at Home Depot and Lowe's. That's the kind of thing you can pick up if you need to. Maybe a friend is coming out of town and they need a way to charge up at your house, and that's what you can offer them. But it'll take all night for their car to charge. But if you get a hardwired unit, 240 volt, the cost range is usually $500 to $700, and then it might only take a few hours for your car to charge. And then we've got the Neo splitter that we mentioned. And what's interesting about the Neo splitter is they do offer it in a variety of 240 volt configurations. So if you need like the NEMA 1030 or the NEMA 1450, you can buy the one that fits the type of 240 volt plug outlet that you have at your house. And a lot of these are Wi-Fi enabled, et cetera, et cetera. There's also a lot of rebates and incentives available for these. So for example, if you're in the community energy, Central Coast Community Energy Range, you could go into 3cenergy.org and look up what level 2 charger rebates are available. Last time we did this course, we had one of the consultants from City of Santa Barbara mentioned to us that also they are offering some EV charger rebates within the city limits. And then there's a resource called Home Charging Electric for All. And you can filter this by your zip code, and they will show you what chargers are readily available and you can filter it by cost. You could filter it by the type of electric socket we talked about, like if it's in NEMA 1030 or NEMA, 1430 or 1450, for example, and you can be connected to available rebates. Now, kind of the last topic we're going to get into. Oh, good. Oh, I'm seeing some stuff in the chat come through. Cool. Okay, so that's good. I guess did any questions come through on the chat on that? I think it's just kind of good to know you can buy these at almost anywhere now, local hardware store if you need one. And otherwise, if you have an electric car, then you're probably looking into getting it hardwired at your house. And then part of all this, okay, so part of the all electric, so we're like, okay, we already talked about in the past courses, the how do you heat your space? You can do that with heat pumps. How do you and cool your space with heat pumps? How do you heat your hot water? You can do that with heat pumps. How do you dry your clothes? You can do that with heat pumps now. And then how do you cook? You could do high efficiency induction, or you still have electric resistance available. And then now with part of this all electric package, we're talking about how do you get the electricity to your house? Is it from, or to your building? Is it from an electric grid that's now cleaned up? Or on-site solar PV? And once you have that energy, how do you store it at the facility to be used later in those electric appliances? And that's kind of the formula for an all electric operational project. The battery storage systems come in all sizes, because we've got utility scale and grid stabilization, where, also known as front of the meter and microgrids that are in front of the meter. And then you've got your commercial and industrial batteries needed for manufacturing processes. And we also have smaller battery systems for private home, and taking those smaller battery components, packaging them up together into a larger cabinet, and with the onboard controls. And then those are being sold for multifamily projects and small commercial. And they're behind the meter, and they can also be set up for behind the meter microgrids for those projects as well. So they can keep operating for small periods of time, independent of what's going on with the giant electric grid. So some of the reasons we're seeing batteries being voluntarily installed on projects, and also part of the reason it's being required for certain types of projects, is for grid stabilization and resiliency. So resiliency is referring to battery use when the electric power goes out. But the grid stabilization or grid stability is really, we're talking about distributed electric resources. Sometimes these batteries installed in different buildings or homes can be kind of connected together in a way, not literally connected together, but the battery resource goes back out to the energy grid and can be tapped. And sometimes when it's tapped as a group, it's being also known as a virtual power plant. And some of those programs exist through your electric utility or the battery provider, for example. So a lot of folks that have Tesla Powerwalls, for a while you could opt in to be part of a virtual power plant, where all the Tesla Powerwalls and under PG&E were being tapped all at the same time to help provide energy to certain areas where the power was being connected or disconnected for a certain portion of time. Most common use for the battery, though, is for load shifting and what's also called self-utilization. So load shifting means you use the battery when the electric rates are highest. So a lot of us were on time of use. The rates are highest from 3 p.m. to 9 p.m. in the evenings. So if you have a battery on site at your house, you can tap your battery and use the battery energy during that period and reduce your overall electric costs. And then the self-utilization is really similar, in it's just basically one step further, recognizing that you have PV solar energy on your roof or somewhere on site. You use that to charge the battery, and then you use the battery later on in the day when the sun isn't shining. And under the code requirement side of it, high-rise multifamily and non-res occupancies are the only type that require a battery under current code, but that battery is only triggered if the solar system that's also required is large enough. So there are minimum thresholds there. So not every project is actually going to need a battery.
Did you know in a multifamily project, depending on the size of your PV, it can trigger the requirement for a battery under current code?
Ask that question again.
No, under the current code is what the webinar I'm listening to is saying. So depending on the size of your array, on Los Olivos, you might be triggering the requirement for a battery array somewhere. Not that you need to know that now, but just something to pay attention to.
Okay. I'm not sure if a person was a comment or they're
It's
accidentally
definitely smart.
muted.
Definitely.
Okay,
Erica, are you? I'll put her on
I'm
mute.
gonna keep
I think that might
going.
have been a mistake.
Okay. For under the 2022 code, high-rise residential, grocery, retail, restaurant, school, warehouse, auditorium, convention center, theater, hotel, motel, office, financial, clinic, medical, office buildings, just those occupancies would potentially require a battery be installed with new construction, only new construction, and that would only be triggered if the PV solar system that was sized for these was of a sufficient size, large enough that you would need the PVs. If you don't need PVs, you don't trigger the battery. So those two go hand in hand. But under the 2025 code, just a heads up, some of these requirements are going to be expanded. So restaurants, for example, there's a dramatic increase in the PV and battery requirement, relatively speaking. But also some occupancy types have been added. So under 2025, libraries, for example, have been added, and that's mostly because they are part of communities' emergency and kind of disaster relief and cooling centers. And so as the libraries are used for that duty, it makes sense to make the library itself more energy independent and resilient. And part of this sort of stems, we go back to the residential scale, is under the old code, PV systems were required, or they're still required for new construction, residential work, and no batteries required. So we're essentially saying, hey, for example, January through December, each month, you're going to use a certain amount of electricity for your space heating and space cooling, hot water, lighting, all your appliances, other plug loads. And we can look at that and get you an average kilowatt hours of energy use per year. And then we would size a PV system if you wanted zero net energy, for example. We could size that solar production. So at the end of the year, you'd make just as much energy as you would use during the year. But we were essentially having the grid, the electric grid, be the battery. So when we're producing excess solar, we're pushing that out to the grid just to either be curtailed, meaning not used, or used by something. And then at night, we'd ask for that energy back. Or during the January, December, winter months, we'd ask for that energy back. And so now the trend is to try and get all our projects, all our buildings to be more resilient, have more self-utilization, and to contribute to the grid stability. So battery's still optional, but we're the new code is that you're going to be battery ready. So in the future, folks can add a battery system as needed. And part of that is you'd have your main panel amp, but nearby you would have a space designated for the isolation equipment or transfer switch with the installed raceways that's needed for the battery system. And also you'd have a sub panel set up for at least 4 branch circuits, but a lot of people, when they get their batteries installed, they often choose to just back up their whole house. Kind of depends on how much battery you need or how much battery you want to pay for. We put this
Jennifer,
slide in here. Oh, go ahead.
Really quick, we had a question from Joanna. Under 2025 code, are existing building renovations included?
No, it's still only new construction, but if I'm incorrect, I will apologize now. And my brain is in this. I should know the answer off the top of my head. I'm going to say right now it's only new construction, but we will be doing our 2025 code update, and I'm going to dive in a little more deeper on what all those changes are under the non-res, those categories for the PVs and batteries. But mostly it's a change in the occupancy type and kind of the amount, but not existing buildings are going to be required for those things. Those will be like voluntary, but maybe extra credit. I don't know if they're offering that even as a credit right now. Okay, I threw this slide in here just to give you an idea of how much equipment you could have. And just kind of FYI, we do see a lot of Tesla Powerwalls being installed, and that controller, that transfer switch I referred to, that is the code language, just in the Tesla parlance, so to speak, it's called a gateway, but it's the same piece of equipment that's needed. And then you'll usually see along with the battery. So this is all the equipment, but a lot of times what you're going to see is something that looks like this, where you'll have the batteries, and right next to it, you'll have your inverters for the solar system, and then the equipment that's associated just with the batteries. And then next to the actual meter and its panel, then you'll have where you backup panel and the controller or the gateway and the equipment in another location. But here you'll have the ability to turn it off if needed, the disconnect and the other connections. I'll show you a picture of what that looks like on my house in just 2 slides. The things to kind of keep in mind is now a lot of the batteries are being installed outside. For a while, we're recommending it be inside because of protection from weather. But a lot of the battery technology, especially like with the Powerwalls, they've overcome that. So you're going to see them outside, and you just need to remember that you're going to keep them 3 feet away from passive travels, doors, windows, follow the manufacturer's requirements. You still want to have to keep them away from temperature extremes. So it's not recommended you put them outside on a wall that sees a direct sunlight. And you're going to protect them from damage. The fire code, this section, you're going to want to also work with not just the building code, but also the fire code. I put this slide in here just as a reference. You'll want to dig in more to that. And then when it comes to the battery systems on the market for the home batteries, it's really starting to expand. There are a lot of brands to choose from, and a lot of them are becoming modular. So you could buy as much as you need. You can stack them up with the controller, or they'll stack behind each other like the Tesla Powerwall does. And to give you an idea about the market growth and the cost, during this time, the Tesla, I think part of its popularity was that it also was some of the least expensive batteries out there for a while. And the kind of the average price is just over $1,000 a kilowatt hour. And a lot of homes, they might install 5 kilowatt hours to 10 kilowatt hours. So it's quite a bit of money. So two things are going to come into play when you're thinking about batteries for home backup. If you're doing it for a non-res project, someone else is going to run the numbers for you. You're going to have a consultant on that. But if you're looking at this for your own home or for that custom residential, and you're working with your clients that are doing residential scale projects, to get an idea of how much battery capacity, what size they need. A couple of the manufacturers, they offer rules of thumb and ways to size the battery by asking questions of like, what do you want to back up? How long do you want to have your refrigerator run, for example? How long do you want your TV to run? Do you want to be able to use your microwave or just a light? And then you can start to decide if you're going to buy enough batteries just to back up a few things or your whole house and for how long. So those are two good websites for that, and two different brands. And then also through PG&E, again, through the guide.pgne.com, you can go to their solar calculator. So it talks about PVs, but then you can look at that and fine tune it for battery use and costs. And you can then take advantage of the software that helps pull together some key financials. So you could start to look at what would the cost be of this battery system in terms of savings over 20 years, what's the break-even point, and that could be based on current average monthly bill. So this is super useful information, especially if you have an existing house in PG&E territory, or you can kind of make up a house just to start to get a handle on these numbers. And under the zero net energy kind of auspices, I put this slide in here too to give you an idea that the code requirement is about 40% of what a typical house uses. So if you're going to target a zero net energy home, you're going to want to maybe double the size of the PV system that's required, and then that size again for vehicle charging if you wanted to include everything. What I've learned from my own project, and this was an existing home, is that a lot of the questions that come up was, oh, did my house need to be re-roofed anyway? Could I take care of repairs on this anyway? And of course, looking at, shading on the roof and solar access, given some areas have a lot of trees. But this also gives you a picture of the new electric panel, and then the sub panel, the backup panel, so to speak, and then the controller, or with Tesla, it's called a gateway. That whole thing is a few feet wide by about 26 inches tall. And then what it looks like installed is on the wall where the middle box, that's the electric shutoff, but the two inverters go to the two Tesla power walls, and then the rest of the electric needs is in the long horizontal box. I had an electric dryer, just not a condensing, not a heat pump, just a standard electric dryer. And I could tell you that on laundry days, when we're doing a bunch of laundry, our solar only meets about 60% of the needs for that whole day. But a lot of the other days, my house is, sometimes I'm 93% self-efficient for a day. Other times depending on the cloud cover, I might be to 60%. But then if that lands on a laundry day, I'm not self-sufficient. So that just gives you an idea, it really depends on how much you're using those electric appliances. Okay, with that, Cook Coach, we're here, we're available, and Chloe's going to tell you about a couple of upcoming courses. And I was thankful for the questions we did have, but I know some of you probably got to go, so feel free, but we'll stay on the line longer as Chloe allows to answer more questions.
Thanks, Jennifer. That was a really great training. And thanks everyone for attending. As Jennifer mentioned, we'll be on the line for as long as you guys have questions. So stick around if you have any questions. I know we had a lot of chat in the chat box today, which was great. So if your question didn't get answered, definitely retype it in or unmute yourself. Just some closing remarks. Thanks so much for coming. If you've come to all 5, thanks so much. We were super happy to have you. And on that note, if you enjoyed these trainings and you'd like to see more like this in the future, definitely take our survey. It will only take a few minutes of your time. It's going to be coming to your inbox in the next few days, probably by Monday. If you have any questions about getting your education units for this course, please send me an email. And then lastly, we have a few courses coming up that you all might be interested in joining, including a green building construction tour in San Luis and the 2025 Energy Code update. I included a link for this in the chat as well. And with that, I will hand it back to Jennifer and Tatiana to answer any questions that you all might have.
Thank you. Okay, I'll do the stop share because we still have a few folks on the call. Because then we can unmute or do the hand raise or chat for questions or comments. Like I know it was lively discussion. I saw a glimpse of it on the induction cooking. And I also wonder if any of you have batteries on your house or are actively, dealing with that, or any feedback on any electric cars and charging, anything like that. I think it would be great just so we can all kind of learn and hear other people's feedback. So unmute yourself and just ask a question or have a comment.
I kind of just had a general question with regards to some of especially the cooktops, the induction cooktops. Are you finding in the people that you're working with that most existing homes have sufficient electrical capacity to be able to support those, or are a lot of people needing to do like upgrades to their electrical panels?
Oh, that's a really good question. It kind of depends on what else they're doing to go towards an all-electric house. So if it's just they're cooking, sometimes they already have capacity because the house may be already had a 240-volt outlet by their cooking area. And then it's really straightforward. And then in other cases, if they're having to have someone come out and cap their gas line and then add electrical, then you might be looking at, $1,000 to $1,500 in addition to the appliance they bought just to deal with running the electric and getting the gas capped. And then there are creative ways to find enough space in most people's electric panels for like one of these upgrades. But what you might find, and like with my own situation, is that after I did the heat pump space heating, because there was an old furnace, cracked heat exchanger on the gas unit. So it was time to just redo it anyway. So time I did that and the cooking and the car charging, et cetera, et cetera. What I had to do when I did the PV system is roll in the panel upgrade all at the same time, because was running out of room, even with sort of creative ways of configuring the existing panel.
And then maybe just a follow-up question, since you brought this up, what do you think for like a typical, home application is say you don't have the capacity to do all of these things, what would you say is kind of the best bang for the buck, or like order prioritization in terms of being more energy efficient? Like, is it better to do the cooking, better to do the heating, better to do the water heating, or does it kind of depend on your unique like use case?
Yeah, I think it's going to depend, but right now, if you have an on-demand gas water heater on demand, and moving to a heat pump, you're probably going to have the more electrical plus the heat pump plus space might be an issue. That might be a bigger architectural thing to deal with. And if your on-demand gas water heater is functioning really well, you might not be ready to swap it out. Plus the cost of the gas water heating, heat pump water heating, they're kind of on par with each other. So you wouldn't necessarily be saving money going to the other appliance. Now with cooking, you get a huge benefit. We didn't really touch on this, but with the cooking, moving away from gas to induction, there is, scientifically data-driven showing that people's asthma is greatly reduced by getting away from gas cooking. They're energy efficient, they're quicker to use. And in my case, I was highly suspect that my gas appliance was not as clean, was slightly leaking. I told you I had a problem with the heat exchanger in my furnace as well. So for me, I just was like, okay, I mean, once I knew that, I was like, yep, that's the first one to change. So that was just a no-brainer in my case. But you don't really save money, but it's better on the health.
And I guess specifically, maybe the better way to phrase that is like from an energy efficiency standpoint, where you see the biggest trade-off, right? If you currently are using gas, like traditional
your heating
gas,
and cooling system.
Heating and cooling. Okay.
Yeah, because then the bigger the energy use, the greater the energy savings. But even like with cooking, a lot of people, when you think about the amount of time you have that appliance on compared to your heating and cooling system, it's very small.
Perfect. Thank you.
And then dryers are another big one. But any appliance that you have an electric resistance and you move to the heat pump, you're gonna get the energy savings. So if you have water, I keep coming back to water, because if you've got an electric resistance tank water, the heat pump, it'll pay for itself in like 2 years. If you've got a gas tank, the heat pump's going to be better for the environment, for energy, but also there's rebates available for people to swap away from a tank. So there's like the caveat with the water.
Hey, Jennifer, this is Andrew.
Some folks, I see a comment in there, they went solar, all electric, except for the cooktop because the run was so long, right? And then Peggy, do you want to, someone was going to say something. Sorry, I didn't mean to cut them off, but Peggy, let's do that. And then Peggy, if you can unmute yourself. Go ahead, Andrew.
I was just going to share in general, our experience with solar and having electric vehicles has been that the time of use factor is extremely important, because oftentimes we have to charge at night from home and the solar is not generating, right? And so then we're still paying delivery and transmission costs from Southern California Edison, which is it's 6 times the cost of the solar. We can set the timing and things like that, but I would just say that the time of use is a huge factor.
Yeah, I agree. I wasn't charging at my house so much. I would just go like the supercharger near me for a while. It was like 38 cents a kilowatt hour. It was even less for a while. It was way cheaper to do that than at the most expensive time at my house. But then now I have the solar and the battery, so I can tell it to charge my car just when I have excess solar. So that's been fun. But it does mean I have to have my car plugged in during the day. Sometimes I'm here at work. That doesn't work. Okay, go ahead, Peggy.
Yeah, I was just gonna say, I love the induction cooktop because it's so much cleaner. It's just like you just wipe it and it's like, yeah, we have a Frigidaire that's 2, 3, 4. I think it's 5 burners and 2 of them you can bridge. So, but like we've been in this house for about a year and there are 8 adults, 3 kids. We have multiple washers and dryers and they were existing. So our next purchase will be a heat pump dryer. But we do have to plan, like when you were talking about the laundry, I thought, oh God, it's a cloudy day, but I had to do laundry today because we have family coming tomorrow. So it's like, you just got to do it. But I can't remember the capacity of the battery storage, and it's not Tesla. It's another company, so we're kind of glad.
That's fine.
Sorry.
We're brand
No, I know.
agnostic.
Yeah, I know.
Yeah. I know it's interesting, right? At first too, I was like on the phone app playing with everything because it was it was fun for me to kind of go, oh, should I use this appliance now or no, or yes or no? And also seeing just what could I do. So when I had these days of being more self-utilization, to me, it was fun. And now I'm more back to back to business of like, oh, that was super fun. But like Peggy said, yeah, we have to get the laundry done. I tell my kid, just get your freaking clothes down there and get it going. I don't care. And then, yeah, we use the grid as our battery. Because we're not an off-grid home. We're an on-grid home that's got the battery there. But the upside was there was we had 3 power outages just last year up in where I live, and we didn't even notice it. I got my high school kid ready for school and took her to school and came back and was like, oh crap, everyone else, the power's out. Wow. So that was pretty fun. That was super fun to not even notice and make my coffee, cook her breakfast. And it didn't, it was fun.
Jennifer, I just want to add one thing to home renovations as I'm doing that on my own house.
Yes.
Making sure that you guys are using a 200 amp panel. That upgrade for San Diego County was roughly $3,000. An existing 50s house with a 100 amp existing panel, just so that everybody can get a sense of cost of that piece of the work. And with that, we ended up doing an electric resistance tankless water heater. Wouldn't really recommend. Not the greatest, unfortunately. And a dual fuel range, and then all new appliances, including an electric vented dryer. With that, and now 2 brand new heat pump HVAC systems, our highest energy bill this summer, when it was 110 down here, was $500. And we were paying a heck of a lot more when we had our gas one. So for everybody, just to echo Jennifer's point, HVAC system first. That is going to be your biggest one. And then water heating, and then dryer, and then unfortunately, as much as I love to cook, the last one's going to be your range as probably your biggest investments, and that's the way I would recommend it, having
Yeah.
done that on my own house.
Yeah, I agree. And then I'd say like you experienced, okay, you had to get the new panel. And then for me, if I haven't done the water heating yet, that's the last one for me, because in my particular case, architecturally, it's just more problematic for me to deal with my water heating. And so I kind of was like, well, I'll do all the other things. Plus, I knew that if I did the water heating and I had already done the heat pumps and the cooking and the car charge, right, that I would for sure need the panel upgrade. So I got the panel upgrade with the PV and the batteries. And
That
now
is
the water
also
heating
that is
is the
also without
last.
solar. I do not have solar
Yep.
on my house, so that's everything without that. So I know solar will help. And we do not have an electric car charger yet, but we did have that factored into this project. So as everybody's looking at their renovations, more so than new construction, just something to keep in mind.
Yeah, that's a great, yes, thank you. I'm so glad you mentioned that, because it does factor in. It definitely factors in. Oh yeah. Okay, so Peggy put something in the comment about induction, super fast and easy to clean. Take second to boil water for morning coffee. That's so funny, because that's my experience too, because I was like using my coffee maker, and then I was like, oh, it's just faster if I heat up a coffee in my microwave and do like the press, because I just needed 2 cups and go. And I'm like, why am I doing that? Because now the induction is like, I scoop the grinds into my little press, and then the water's boiling and pour it in. That's how fast it is. It is fun. It is. But for me too, like I did have this additional costs incurred for capping the gas and having to have 240 brought to where in my kitchen. And I have a crawl space, so it was easy for the electrician to deal with it. But I had asked them, what are you doing when folks have like slab on grade? And he's like, well, we could try and run it up and over and other ways to route it, but the cost goes up. And then suddenly the induction appliance isn't as exciting unless you're doing a whole kitchen renovation. And that's kind of where that has fallen for a lot of people we've noticed. Yeah, but great comments. I appreciate everyone adding their comments to the chat and sharing their experiences. I think I look forward to hearing more about all these as we continue to do these classes, and as we all kind of learn from each other, as well as we're all sort of navigating how these new appliances are working for people, and also if they're liking their new heating system or liking their new water heating system. Sounds like maybe not on the electric on demand. I'd love to hear more about that, because you can do that for ADUs under the new code. Yeah, feel free to comment about that water heating experience if I'm not sure if you've jumped off yet, but I think we probably have just another minute, and then we'll all have to jump off. Okay, I think that's it. Gonna close us out here, Chloe.
Yeah, thanks so much for being here, everyone. Thanks for a great 5 classes, and we'll see you for the next one.
Thanks, everybody.